Hello, question number 4a. So when the magnet bar moving to the coil, so meaning the you can see you have a deflection of galvanometer. So why the galvanometer deflections to the right or to the left? Because of, let's say you have a magnet bar, so this is S south pole and this is north pole. So when the magnet bar moving to the coil, so meaning the number of flux, okay, the number of the flux here, because this is N, this is right, this is S and this is N, right? So when the magnet bar moving to the coil, the number of flux pass through to the coil, meaning you have the change of flux time t. So according to the Faraday, if you have the change of the flux, meaning we have a current flow in the coil. That's why if you connect it to the galvanometer have a deflection to the left or to the right, right? So if this is N, so when the magnet bar moving to the coil, so we have this the green color, we have another B here, produced by the induced current that oppose to increase of flux by the bar magnet. So meaning if the direction of the galvanometer to the right, when you magnet bar moving to the coil, if you move out magnet bar from the coil, so the deflection of the galvanometer is opposite direction. So if you're moving out magnet bar from the coil, so the produced B here is S. If you moving magnet bar to the coil, so the magnetic field produced by the current I is a N, right? So this is from the Faraday and Lenz law. Question number 4b. A rectangular coil of 250 turns and size 20 cm and 30 cm rotate at constant angular velocity of 500 rpm in uniform magnetic field 40 millitesla. So you see you have a rectangular coil with a number of turns is and 250 and the size is 20 30 cm. So you have a magnetic field pass through to the coil. This is magnetic field P, right? 40 millitesla, and the coil is rotates up and down, meaning you have a change of the flux or cut the magnetic field B, so meaning you have a induced current in the coil here. Or now you can use induced EMF when the coil starts moving or rotate. And coil rotate at constant angular velocity 500 revolution per minute or 500 RPM. So number one, what is the maximum flux? So how to calculate the flux? The flux is a BA cos theta, but this is the maximum. So meaning if you find the maximum value of the flux, that's why the cos theta is equal to 1. So the flux here, this 1 is equal to BA. Now the B is 40 millitesla, right? B is a 40 millitesla, and the area of the A is equal to, because centimeter, so convert to the meter is a 20 is 0.2 and 30 is time, 0.2 times 0.3, right? So now you can find the flux is equal to 0.0024 Tesla meter square. Right? Oh, can use a unit for the flux is a Weber. Sorry. Now the question number 2, calculate the voltage produced by the coil. So now if the coil start rotate and induce current or induce EMF in the coil here, E is given by the EMF is given by the NA B omega sine omega t. So this is the equation or induced EMF in the system, right? So to calculate the induced EMF, so now you have a number of turns is 250 and the area A is equal to 0.06, right? 0.3 times 0.3, and the B is 40 milli is 0.04 Tesla. So now the omega here, so right here, right? So what is the omega? As you know, omega is a angular frequency is equal to 2 pi f, 2 pi constant f frequency, and the frequency given is, no, you don't have the frequency. Yeah, no need for you to calculate the frequency because, yeah, this is the value of omega, but omega here is a 500 revolution per minute. So you must convert to the omega is a radian per second. So you know how to convert it. So as you know, 1 revolution is equal to 2 pi. So 500 revolution, so omega is equal to 500 times 2 pi divided by, because this is per minute, so this second is divided by 60. So this is how you can find the omega here, right? And the sine theta, sine omega t here, so right here, sine omega t, or you can use the omega t is equal to theta, and the theta here is the angle between B and the coil, area coil. So the information here is when the coil makes angle 30 degree, so meaning you have a B here, and the position of the coil here is a 30 degree. Right? Between this is coil and B, but the angle here, so this is the angle, the area A, right? Area A is theta is between B and A, right? The A area. So the area A here is equal to 90 minus 30. So the theta is equal to 60 degree. So theta is equal to 60 degree, right? So all the value is complete here. Yeah, you can use the calculator to calculate the induced EMF or voltage produced is equal to 27.2 volt. Next question, what is the maximum voltage? Maximum voltage. So as you know, the maximum voltage or induced EMF so that is equal to N A P omega sine omega t or sine theta. So if the question asks you maximum voltage, meaning to find the maximum voltage or maximum EMF, the value of the sine here is equal to 1. So this is equal to NAB omega, right? So all the value here is the same. If you look the right question number from question number 2 here. So n number of turn is 250, A is equal to 006, and B is B is 004, and the omega here is equal to 500 rpm, but convert to the radian per second, right? So can use the calculator to calculate the E maximum or voltage maximum is equal to 31.42 volt.